All right, welcome to lecture 5. Really am honestly going to try and keep these shorter because I really want to focus each of these next few lectures down to one specific idea about sound. Because what we're going to be doing now is moving into this section, we've talked about recording techniques, and we're going to leave the concepts of recording techniques behind us for now and really look at what is sound. This is actually, we're going to get kind of into the science of things. At its core, what is sound? Sound, well, the fancy definition of sound is that sound is the energy of a vibrating body that was transformed into a medium, usually air, and travels as a sound wave through that medium, and there is a cycles per second component. The much easier way to think about it is that sound is the vibration of molecules in an elastic medium with a cycles per second component. This is the really important thing. You need to have a cycles per second component. Further elasticity is the ability to return to the original shape after displacement. Air is an elastic medium, believe it or not, even though we can't see it, we do feel it when the wind blows. But air is an elastic medium where if you push it, it will want to go back to where it came from. If you don't believe me, take like a balloon, push a balloon, you'll feel the balloon push back. When an object vibrates, the air molecules surrounding it are displaced. That means when something vibrates very quickly, it's going to push the air molecules around it just as quickly and displace them, push them away. After the original disturbance of those air molecules, they'll want to come back to where they came from. Right. Another way to look at it is what's happening is you have a displacement, and typically you diagram sound waves in a waveform pattern like this. You've probably seen this in school. What this is showing is that this straight line down the middle, that is considered zero pressure. That is air with nothing added to it. When the curved line here, what this represents that is showing the displacement. This is the push of the air. And then this line is representing time. This line going this direction with zero pressure, but when it's moving in that direction is talking about time. So as time moves on and then pressure is pushing, when we reach this top point, that is our maximum pressure. And then it's going to continue down, and that's going to be our minimum pressure. And then it carries on and so forth. Sound waves are a series of air pressure changes caused by a vibrating source. The vibrating disturbs the air molecules. They squeeze together and then pull apart, transferring the energy kinetically from one place to another, causing a continuous wave. You'll read about this in Chapter 3, which will be your next reading assignment, coincidentally. Compare this motion to an ocean wave where you can see the water levels rise and fall. Sound waves move pretty much in the exact same way. Alright, so this is maybe a better way to show what's going on. If you look at this, here, whoops, let me get a better marker here. These are our regular air molecules. When the sound waves push, basically when that cone here pushes out, it pushes those air molecules in forward and they compress into one another. And this is called a compression. Let me clear this. And then what happens is as those air molecules compress into each other, compress into each other, compress into each other, compress into each other, compress into each other until it reaches our ear, and then those air molecules hit our eardrum, and then we transfer that into sound. Now, those air molecules don't always keep going forwards forever because this is an elastic medium. It wants to come back to where it came from. So what happens after those air molecules push forward and hit the next air molecules, those air molecules are going to go back to where they came from. And this is called rare refraction. So you have a compression followed by a rare refraction. Compression, a vibrating source pushes those air molecules, and then they travel along, travel along, travel along, and then they want to go back, and that's a rare refraction. All right. What I'd like you to do is go back and take a look at the roughly first 5 to 7 minutes of the Filmmaker IQ video that is on the what I would like you to do is go back to the Filmmaker IQ video that is in the first analog audio folder and watch about the first 5 to 7 minutes of it, where he talks very much in depth about this concept of compression and rare refraction.